Question 31. Solve the following equations simultaneously. We have 2x plus 3y equals 4 as equation 1 and 6x minus y equals 2 as equation 2. We can solve this simultaneous equation by substitution or by elimination. But in this case, we'll be solving it by both elimination method and substitution method. So students can understand or can be well grounded in both elimination and substitution method. Method 1. Simultaneous equation by elimination. Let's start with elimination method. Let's eliminate x. For us to eliminate x, the coefficient of x here has to be the same as the coefficient of x below. Let's say this is equation 1 and the lower one is equation 2. For us to eliminate x, the coefficient of x in equation 1, that's the number in front of x in equation 1, has to be the same as that in equation 2, which is 6. We have to increase 2 to 6, and we have to do it by multiplication. So we have to look for a number that will multiply by 2 to give you 6, thereby making both of them have the same coefficient. Then we subtract to eliminate x. We know we have to multiply 2 by 3 to get 6. So everything in the first equation will multiply by 3. We have equation 1 times 3. For us to still maintain this 6x, equation 2 will multiply by 1. 1 times any number is still that same number. Everything on equation 1 will multiply by 3. So we start with 3 times 2x. Or we can say 2x times 3. 2x times 3 is 6x. That's this 2 times this 3 is 6. With the x, that's 6x. Then we go next. 3 times 3y. This 3 will still multiply by plus 3y. This 3y owns this plus, so we're multiplying 3 by plus 3y, or plus 3 times plus 3y. So we have 3y times 3. When it's positive, you don't really have a problem. 3 times 3 is 9. Then the y, you have 9y plus 9y equals 3 times 4 is 12. This is 12. That from equation 1 we derived equation 3. We multiply everything in equation 2 by 1 is still the same value, so we can call it equation 2 or equation 4. We can leave it as equation 2. It doesn't really matter since it doesn't change or nothing has changed. We just converted equation 1 to equation 3 by multiplying equation 1 by 3. We can still leave equation 2 as equation 2 since whatever we multiply by 1 is still that number. So we have 1 times 6x is still 6x. 1 times minus y is still minus y. Then we have 1 times 2 is 2. We can still leave this as equation 2 since nothing has changed. If the values or the signs are changed, we would have named it equation 4. There's no crime in still leaving it as equation 2. Now that the coefficient of x here is 6 and is 6 here, or we say plus 6 and plus 6 here, it has to be the same number with the same sign. Then we subtract. We have 6x minus 6x. Let's write it out. 6x minus 6x is like saying 6 minus 6 is 0. And that's the real reason why we made them both the same, so we can get it to be 0 or we can eliminate it. Therefore, we put a dot here. Then this is where it gets technical. You have to be very careful here. This y is the same thing as 1y owns this minus. Here is where you have the technicality. And here is one of the reasons why students find math hard. Let's do it on this other side. On our right, we have plus 9y, this 9y owns this plus, minus 1y or minus y. This y owns the minus 2, so you have minus y. We have 9y, same thing as plus 9y is still 9y. Minus, you have to resolve it into 1, you have to make it 1. And they are linked by times or multiplication. So minus times minus is plus, so you have plus y or plus 1y. You can make it 1y. If you're finding working with y alone quite hard, you can make it 1y in your rough work. 9y plus 1y is 10y. So this is 10y. If you had jumped on it and say plus 9y minus y, you would have gotten 8y and you'd have gotten it all wrong. So this is 10y. We have the last part of the subtraction, which is 12 minus 2. Since it's positive, it's not always dangerous. We have our equals to sign. 12 minus 2 is 10. We have this as 10y equals 10. We're looking for our y. Since we have eliminated our x, we divide both sides by the coefficient of y, which is 10, to get the 10 off the y. Divide by 10 divided by 10. 10 cancels 10. Y is equals to 10 divided by 10. That's 1. Y is 1. You know our Y is 1. And with our Y as 1, we can find our X using any of the equations that we prefer. We can use equation 1, we can use equation 2, and we can use equation 3. Using any of the equations, you still get the same answer for X. Let's just use equation 1. You have 2x plus 3y equals 4. We know our Y is 1. So we're now changing Y from a letter to a numeric value or to a number as 1. Y is linked to 3 by time, so you have 2x plus 3 times 1. You know the Y is 1, so we change the value of this Y to 1 equals 4. 2x plus 3 times 1, that's 3, equals 4. We start by taking out the constant. 2x equals 4 minus 3. Plus 3 crosses the equals to sign and turns to minus 3. You know, we want x alone on one side. Now I've gotten the 3 out. We still have the 2 with the x. We have 2x equals 4 minus 3, that's 1. Since we're looking for x, we divide both sides by the coefficient of x. That's the number in front of x joined to x. We divide both sides by 2. 2 and 2 here. 2 cancels 2. X equals 1 over 2. X is half. That's for our answer, x is half and y is 1. From our options, our answer is C, where x is half and y is 1. Method 2. Simultaneous equation by substitution. We're solving this question using substitution method to show if you either use elimination or substitution, you still get the same answer. Using substitution, I prefer the letter with the coefficient of 1 or minus 1. In this case, we have x here has 2, y here has 3, and in this case, x here has 6, and y here has not just 1 but minus 1, because the y owns the minus in front of it. But I prefer working with this and making it the subject of formula so as to avoid fractions while solving. So I'll pick equation 2, and from equation 2, I will make y the subject of formula, thereby creating equation 3. And with that equation 3, which I can't substitute back into equation 2, I can only substitute it into equation 1. Then I find the value for my x, then my y. So let's take equation 2, where we have y with a coefficient of minus 1. We have 6x minus y equals 2. I want my y to be positive, so I take this minus y, I take it over the equals to sign, turns to plus y. And I take this plus 2, I bring it in, it turns to minus 2. So we have 6x, then plus 2 crosses the equals to sign and turns to minus 2 equals minus y crosses over the equals to sign and turns to plus y. You can write y without the plus. So it means from equation 2, we created equation 3. In equation 3, y is equal to 6x minus 2. Still the same thing. Leaving y on the right or putting it on the left still means the same thing. Y is 6x minus 2. From equation 2, we created equation 3. We can no longer substitute equation 3, which was created from equation 2, into equation 2. We can only substitute it into equation 1. So we write out our equation 1 again. Equation 1 is 2x plus 3y equals 4. Here, from equation 3, y is 6x minus 2. So where we have y in equation 1, we change it to 6x minus 2. So we have y here. So we have 2x plus 3 into open brackets, because y represents 6x minus 2. And this 3 affects the y. Therefore, it affects everything that represents y. So you have 6x minus 2, close bracket, equals 4. We can then solve for x. Now we see that we don't have two unknowns in the question. We just have only one, which is x. Y is off. By making y subject of formula and substituting that value into the other equation, we got y off it, and we now have x. We can now solve for x. We have 2x. Now this 3 owns this plus, and this plus 3 affects both the 6x and the minus 2. That means the 3 multiplies the 6x and the minus 2. So we have plus 3 times 6x. Just since it's addition, you can just leave your positive. Positive doesn't come with troubles, unlike negative or minus sign. So we have 3 times 6 is 18 with the x. So you write your x here, that's 18x. Then you have plus 3 times minus 2. That's plus 3 times minus 2. Plus times minus, by now you should know is minus. Then 3 times 2 is 6. So you have minus 6 equals 4. On the next line, we add our x's. We have 2x plus 18x, that's 2 plus 18, that's 20 with the x, we want x. That's 20x minus 6 equals 4. On the next line, 20x equals 4 minus 6 crosses to the other side of the equals sign, it turns to plus 6. We have 20x equals 6 plus 4, that's 10. We're looking for x, so we divide both sides by 20. That's the coefficient of x. 20 cancels 20, x equals 10 divided by 20. You can say 0 cancels 0, x is half. We can see our answer is the same as the one we got using elimination method. We now know our x is half. Since our x is half, we can substitute it into any of the equations. We still get the same answer. Let's just use equation 1. Equation 1 says 2x plus 3y equals 4. We know x is half. So we have 2 times, 2 is linked to x by times. So you have 2 times. The value of your x is half. So you have times half plus 3y equals 4. We can make this 2 over 1. 2 into 1, 2 into 1. So 1 times 1 over 1 times 1 is just 1 plus 3y equals 4. We're looking for our y, so we prefer to have our y on the left. This 1 has a plus, so it goes over the equals to sign and turns to minus 1. We have 3y equals 4 minus 1. 3y equals 4 minus 1 is 3. We're looking for y, so we divide both sides by the coefficient of y, which is 3. Divide by 3, divide by 3. 3 cancels 3. Y equals 3 divided by 3. 3 divided by 3 is 1. We therefore know our x is half and our y is 1. Same answer using both substitution and elimination.